but we learn only 3. But the other 3 just reciprocal. So every book just teach 3 for geometry class. But after the class of geometry, maybe add 2, the teacher will show you somewhere else. Okay, please. For we have geometric ratio is the ratio of the length of 2 sides of a right triangle. First, right triangle. The relationship of 2 sides make a ratio. Trigonometric ratios are used to find the measure of a side or acute angle in a right triangle. So it's very important. For instance, if we have a triangle, right triangle, ABC, give you this angle is 30 degrees, give you this side is 2, you can find other sides. You can find every another acute angle. So give you 2, for instance, give you 1 length, give you 1 angle, you can find others. We call this one is a soft right triangle. After solve the right triangle, we can solve any triangle, but we need something else. Okay, please? So the ratio of 2 sides is very, very important. Make a trig ratio. So first, we have sine to go. Okay, please? The sine. The sine of an acute angle in a right triangle is the ratio of the length of opposite sides over hypotenuse. You know, we have 2 sides. One side is opposite, another one is adjacent. For triangle ABC, with the angle A, opposite is BC, adjacent is AC. Do you understand, please? Here, opposite leg means opposite side, means opposite, the leg opposite to angle A. So the leg BC is opposite to angle A. For angle B, opposite is not BC, is AC. You understand, please? So opposite side, opposite angle must be clear. Okay, please? The definition is OPP dot stands for opposite. So opposite side of angle A over length of hypotenuse. For this particular question is BC over AB. Hypotenuse is AB. So BC over AB for this question is sine A. You write SIN space A is sine A. Everyone in the world can understand it. You don't need to write SINAEA. Nobody writes like this. Okay, please. You can write sine A, but other people can understand you is fine. Understand, please? But I hope you write SINA clearly. Okay, please? Again, angle A definition, the sine of angle A, write as SINA equals to angle A's opposite side, opposite leg over hypotenuse. And the same thing for cosine, almost the same thing. You find the opposite. Now you need to find the adjacent of angle A. Okay, please? I'm sorry. Angle A, the opposite is for sine. For cosine, you need to find the adjacent side, adjacent leg. Same thing, angle A adjacent change to AC. Hypotenuse the same AB. So AC over AB is angle A cosine ratio. You don't need to write cosine. Okay, you just write COS space A perfect. Okay, please. Cosine A again. Adjacent of angle A over its hypotenuse. Yeah. Now we have last one. We call this one as tangent. TANGENT. We use TAN A, tangent A is enough. Nobody use TANGENT, but in other countries, in Europe, you use TG, means tangent. Use CTG for cotangent, but we use COT for cotangent. Tangent, cotangent is reciprocal, we don't discuss. We only discuss tangent, TAN and A. Tangent has nothing to do with hypotenuse. It's opposite leg over adjacent leg. You can see angle A, opposite is BC, adjacent is AC, BC over AC. First two sine, cosine, hypotenuse is related, but tangent, hypotenuse is not related. That's the difference. Okay, please. Now, something is still confused. I'm still confused. How to get this part is the highlight not only for today, but also for this week, for next week. Okay, please. I give you some questions here, please. If you can remember the definition, I think this question is easy. If you cannot, we go over together. Who is the volunteer? Give me sine x. Yes.
Sine x is 15
Mm-hmm.
Over 25.
Over 25. Is that correct?
No.
15 over 25 is that correct? Uh-huh.
Oh.
Is correct?
Yes. Yes.
Is correct? Yes. Opposite over hypotenuse. Perfect. 15 over 25. Then you can reduce. Divided by 5 is 3, divided by 5 is 5. 3 over 5. 3, 5 is a ratio. This ratio is called angle x sine. So sine x equals 3 over 5. 3 over 5 is not length, is not a degree, is a ratio of two sides. Do you understand, please? So is the angles opposite side over hypotenuse, the ratio. Sine y equals what? Sine y. 20 over 25. Is that correct? Yes or no? So you can see opposite. 20 is opposite. 25 is hypotenuse. So it's 4 over 5. Is that okay, everyone, please? Good. Yes? No? Why is this angle? Opposite is 20 over hypotenuse. This is x. Opposite is 15 over 25. Sine is gone. Cosine x. Who is the volunteer? Tell me cosine x. Yes? 20 over 25. Smart. Good. 4 over 5. Thank you so much. Because the cosine definition is adjacent over hypotenuse. Adjacent is 20. 20 over 25. Cosine y. Who is the volunteer? Yes? 15 over 25. After reduce is 3 over 5. Some students say, oh, this is very strange. Sine x equals cosine y. Sine y equals cosine x. Yes. Who can tell me how to get sine x equals cosine y or cosine x equals sine y? How to get this? Who can tell me, please? What is the condition? What is requirement? X, y should be what? X, y should be complementary. Yes. So x plus y must be 90 degrees. If not 90 degrees, this doesn't work. Okay, please? This is one of the trigonometry identity we will learn very soon. Okay, please? Not for geometry class, for maybe pre-calculus algebra 2 class. Now we focus on the ratio, which side over which side. Sine, cosine, we summarize again. X is this angle. Sine is opposite over hypotenuse, but cosine is adjacent over hypotenuse. Last line, tangent x, yes? 3 over 4. Oh, this young one just too fast. Okay, skip. 15 over 20. Reduce is 3/4. Thank you. Good. So x opposite over adjacent, reduce 3/4. How about tangent y is what? 4/3. 3/4, 4/3, they are what? Reciprocal. Okay, good. Tangent is reciprocal. How to make those two are reciprocal? Who can tell me what is required? What is condition? There are two angles should be what? Two angles complementary, yes. If x plus y equals 90, sine x cosine y, cosine x equals sine y, and tangent x, tangent y equals 1. The product is 1, means reciprocal. Do you understand, please? Good. For instance, 3/4 times 4/3 is 1. Now, if you really understand this, you remember the definition. We worked for yesterday's, this one together, okay, please? Look at the board, please. First, we have this one, yesterday everyone was here. Sine 30, 60, 90 degrees. We have, that's why my way is better. 1 square 3, 2 is better. 45, 1 square 2 is better. Now, who is the volunteer to sine 30 degrees? Who is the volunteer to do this? Sine 30 degrees. You should know, yes?
1/√2.
1/√2, no.
I was gonna say just 1/, because I can't really see as a square root, but I see
1/√2. But I cannot hear you. Maybe you're right.
Does the 2 have the square root over it? Because I can't see you.
It does. Oh, is it the right triangle?
For right triangle, yes, this is right triangle, right triangle. Yes?
1/√3.
No?
1/2.
Yeah.
Yeah. So, the answer is 1/2. Okay, please? Sure. Some students, I still don't get. Look at the board. You still don't get it, it's not your fault. Many students sitting in the calculus class, they still don't know this, okay? You're okay, good. You get this one is really, you get this one, you're really good. You're better than some people sitting in the classroom of calculus. This is yesterday we learned. This is 1, this is 2, 30 degrees. Opposite is 1, hypotenuse is 2. So 1/2 is sine 30 degrees. Understand me or not? Yesterday we discussed 30, 60, 90 degrees. We have x, 2x, square 3x, don't use x, okay, that is not good idea. Use small number, 1 square 3, 2. 1 square 3, 2 is much better. The definition for sine is its opposite side over hypotenuse. Hypotenuse for 30 is 1, this is 2, 1/2. Is that clear? Sine is 45 degrees. Who is the volunteer? Yes?
Square root of 2/2.
Square root 2/2. Okay, how to get square root 2/2?
Oh, for the sine, is the length will be opposite to the hypotenuse. So, based on like, when we talk about a 45-degree angle, and like both of them would be like the same since they're isosceles. And there's 2 of them, which means and then you say square root of 2, so it's square root of 2/2.
Yes?
Without simplifying, it's 1/√2, and then you rationalize it by multiplying √2 and √2, so then it's √2 and √2.
Can you repeat again?
Yeah. So without simplifying, it's 1/√2, and then you rationalize it by multiplying √2 and √2, and 1 times √2 is just √2, and √2 times itself is 2.
Do you understand her, please? Thank you so much. I write on the board, okay? It's not your fault. 45 degrees, for instance, this is 45 degrees. Opposite is 1, hypotenuse square root 2, so 1 over square root 2 is excellent. But 1 over square root is not simplified. How to simplify? 1 over square root 2 times square root 2 over square root 2. Square root 2 times square root 2 is 2. 1 times square root 2 is square root 2. So that's why he got square root 2 over 2. We don't need, if you cannot simplify, this is good enough for my class. Do you understand, please? 1 over square root 2 is good enough. Square root 2 over 2 is perfect. Simplify. So, good. Now, sine 60 degrees. Yes, good. Square root 3 over 2. Perfect. Thank you. Yesterday you was asking me, right? No, I'm sorry. Square root 3 over 2. You can see 60 degrees. This angle opposite is square root 3. Hypotenuse is 2. Thank you so much. Is that okay? If you understand now, you are better than some students in the calculus class. If you are still not get this one, it's okay, because you have 3 more years to go. Do you understand, please? Sine is opposite over hypotenuse. Opposite over hypotenuse. 30 degrees, opposite is 1. 2 is hypotenuse. 45 degrees, opposite is 1. Square root 2 is hypotenuse. 60 degrees, opposite is square root 3. 2 is hypotenuse. So easy, right? Not difficult work. Cosine, 30 degrees. Yes?
1 over 2.
1 over 2, is that correct? Cosine 30 degrees.
Oh, 30 degrees. Oh, I messed up. I thought it was 60.
Yes. Is what?
Yes.
You have to find it. Yes? Yes? This is my students, okay? Good. Cosine is what? Adjacent over hypotenuse. 30 degrees, adjacent is square root of 3 over 2. Good. Cosine 45 degrees. Cosine 45 degrees, yes.
Root 2 over 2?
Square root 2 over 2, yes, because they're the same thing, yes. It's also 1 over square root 2. Square root 2 over 2. You can see, because adjacent is also 1. 1 over square root 2 reduces square root 2 over 2. Good. Last one, cosine 60 degrees. Some students didn't raise your hands. I hope you raise your hands. You made a mistake. Maybe other people can help you. You can remember for a long time. Yes, who is one? Yes? 1 over 2. Thank you. Cosine 60 degrees. Adjacent is 1, hypotenuse 1 over 2. Now, you can see sine 30 equals to cosine 60. Sine 60 equals to cosine 30. Yes, we discussed it over there. So again, sine cosine denominator is always hypotenuse. 2 or square root 2. Yes, please. 2 or square root 2. The difference is sine is opposite over hypotenuse. Cosine is what? Is adjacent over hypotenuse for sine for the 60 degrees. Now, tangent 30 degrees. Yes.
1 over square root 3.
Yes. Now, so this semester just changed. Yesterday, today, just perfect. Okay. Keep working. You must be really good. Okay. 1 over square root 3. You can see 30 degrees. Opposite is 1. Adjacent is square root of 3. 1 over square root 3. Simplify is square root of 3 over 3. But I just leave there. You can do by yourself. If you cannot simplify, I told you it's not perfect, but it's okay in my class. Tangent 45 degrees. Nora, I know you know that. I want some other students, okay? To be better. Tangent 45 degrees. Tangent definition is opposite over adjacent. Look at this word. Opposite over adjacent. Yes? 1. After this one, adjacent is also one. 1 over 1 is 1. Do you understand, please? So that's why before you use calculator for tangent for 35 degrees, you have to check your graphing calculator, TI 4084 plus or something. You have to check tangent 45 equals to 1, perfect, equals to 1.6 something, not okay. You have to change the calculator. Many students for PSAT, SAT use calculator for tangent, but very few questions for tangent. Okay? If you use tangent, you made a mistake. So you have to be careful. If the mode is degree, you get a 1. If the mode is radian, you get 1.6 something. Before pre-calculus, we use degree. Calculus, we use radian the most. So we have 2 modes for calculator. How to check? You check tangent 45 equals 1 means your mode of calculator is okay, is in degree. If not, you have to change. Okay, so tangent 45 equals 1. Last question, tangent 60 degrees. Yes? Square 3 over 1 to square 3. Perfect. Now, how many students understand this? Raise your hands, please. Most students are better than calculus class students now. Okay, you are better. You are good. I tell you the truth. I told you yesterday, one student, I went to another campus. In our campus is better. Still have some students, they still don't know sine 30 is 1/2, cosine 30 is square 3 over 2, and the tangent 45 is 1. They still don't know. They have to use calculator. You don't need calculator. Do you understand, please? For this part. Now, some students still cannot get this part done. I prepared, I think it's okay for some students.